Video, we will explore how to represent molecules and compounds through naming and structural drawings. In this video, we will explore how to represent molecules and compounds through naming, drawings, and formulas. So there are three different main types of formulas that we use in chemistry: the empirical formula, the molecular formula, and the structural formula. We'll start first by looking at the molecular formula. This gives the identity of and the number of each element in a molecule. So for example, the common name for a molecule called benzene has 6 carbons and 6 hydrogens. So its molecular formula is C6H6. These values here represent the number of atoms of that particular type of element. So for benzene, there are 6 carbon atoms and 6 hydrogen atoms in one molecule of benzene. The empirical formula is a little bit more simple than the molecular formula. The empirical formula is the simplest positive integer ratio of atoms present in a compound. So this gets to the law of multiple proportions, which you learned about a few units ago. So the law of multiple proportion states that when two elements form a series of compounds, the ratios of the masses of the second element can always be reduced to small whole numbers. Okay, that's a lot of fluff. So let's get into what that really means. If benzene has C6H6, well, that means it's just a 1-to-1 ratio of carbon and hydrogen. So the empirical formula then is CH. Let's do another quick example. If we had a molecular formula of C6H12, now this is a 1-to-2 ratio. So then our empirical formula would then be CH2. Great. And then the last main type of formula that we look at is the structural formula, and that shows the actual connectivity of the atoms. And so again, using benzene as an example, we have 6 carbons and 6 hydrogens, and in this structure, carbons are bound to one another in a cyclical structure, and then each carbon is bound to one hydrogen. And remember that a line represents 2 electrons being shared, and in this case we have a double bond, which means that there are 4 electrons being shared. There are 2 bonds between this carbon and this carbon. Great. There are a couple of other ways that we represent compounds commonly, and these are more just ones that I want you to be able to recognize. I'm not going to ask you to draw them. We've already looked at molecular and structural. This example here is methanol, or wood alcohol. So molecular formula CH4O, so 1 oxygen, 4 hydrogens, 1 carbon. The structural formula shows that connectivity of those atoms, that the carbon's central and the carbon's bound to 3 of the hydrogens, and then 1 oxygen, and then 1 of the hydrogens is bound on that oxygen. And you could also draw this with a single bond there, or just write the OH next to each other. Okay, the ball and stick model, again, these 3 you won't have to draw. The ball and stick model is just showing the same thing as the structural formula, but more in 3 dimensions, and usually white is hydrogen, black is carbon, and red is oxygen. And then a perspective drawing is just showing the structural formula, but in 3 dimensions, because these molecules are 3-dimensional. So this wedge means it's coming out, and the dash means it's going back. And then a space filling model is similar to a ball and stick model, but it's actually showing the size of the electron cloud.